This use case is about a digital twin of an industrial drive-through motion control system. This basically consists of an electric motor that is controlled by a motion control platform with a real-time operating system, and on top of that we have field-oriented control for controlling the motor. Motion control systems, they have quite strict requirements in timely and precise control. And besides that, we also have to make the systems be compliant with safety and security standards. Well, there are several needs we have in our domain. So one of the most important ones, I would say, is when it comes to upgrading an existing platform with new components. Usually this means a huge verification effort, and it is high risk and high cost to do that. So what we are looking for in this project is to find methods to ease the verification validation process there and reduce the cost and the risk with that. So this is one thing. Then additionally, what's important are methods for automated finding of fault injection points in the design. This is also a thing. Then what we else have is we need methods that can help us to specify signal behavior, so not just in a discrete but also in a continuous domain, so that we can also verify, for example, the behavior of currents or speed of a motor in a formal way. So luckily we have a lot of partners that support us there. So for one thing, we have the Austrian Institute of Technology. They are helping us with real-time monitoring techniques. So this means we can formally specify how the signals should look like, and with the RTI AMT tool, monitors are created that help us to verify if the system behaves correctly and the signals follow the specification. Then another thing is that we want to have as few test cases as possible, but at the same time have a complete verification. And for that we have VALU3S and also ALT that help us to model our system in UML and then use mutation testing to generate test cases and optimize test cases and possibly find new test cases for our design. So this is VALU3S and ALT. And then we also have a digital twin methodology that we are piloting, where we build a digital twin of an existing system and replace a component, a CPU, with a new one and see if the behavior of the new component is still the same, or at least to a certain degree the same, so that we can say it is possible to replace an existing CPU with a new one.